So I want to take this one more step now. I want to look at something like this. I want to take this guy right here. And if you noticed, he's got a fractional exponent. What does that mean? Well, let me show you how to change this from a fractional exponent into a radical. Okay, so look at this guy first. You know that this is 5 over 3. And do you see the little line here? Watch this. This is going to be this line right here. Now, if I write this as 5 over 3 on this little diagram that I have here, and I know it's a flower and you're going, what the heck's with that? Patience, I'll show you. Look what grows beneath the soil. That's right. There's the roots. The roots in this case is 3. That means that this is going to be a cube root. See what I mean? Haha. So what does this 5 mean? Well, it's the flower, which is the power. Awesome, right? So flower power, that's 5. So there's your exponent. There's your root. So what does this thing over here become? Well, okay, let's try it again. Watch. X to the exponent 5 to the root 3. So you can write this as the cubed root of x to the 5. There's the power right there. There's the root right there. Or you can write this as the cubed root of x all to the power of 5. Either way, doesn't matter. They're both exactly the same. They'll give you the same result. So what does this mean? Let's keep on going then. Take a look at this question now. It says express as a radical, then evaluate. Don't forget your flower power. So look, right? 3 over 2. There's your 3 over your 2. So your 2 is your root. Your 3 is your exponent. So check this out. This would be the square root of 25 to the power of 3. That's how you do it. Now, what does the word evaluate mean? The word evaluate means put it in your calculator. Okay? So you can write this way, or remember, you can write this as the square root of 25 to the power of 3. I like this method. I like doing the power second. And one of the reasons why I like doing the power second is because when you square root, you're dealing with a smaller number. Look at that. So 5 to the power of 3 is 5 times 5 times 5, which is 125. Look what happens with this one if you happen to do it this way. You need to do 25 to the power of 3. I have no idea what that is, so I'm going to bring up my calculator. 25 to the power of 3 should be a huge number. Yeah, no kidding. 15,625. Holy smokes. And we're going to take the square root of 15,625 and watch what happens. I'll bring my calculator up and I'll take the square root. Second square root of the second answer, and look what I get. I get 125. So this works out to be 125. I think this way, I don't know, I think it's easier, right? So you might want to put a little note here for yourself saying, do the square root or the root first, okay, and then the power. It doesn't matter, it'll give you the same answer, but doing the root first might allow you to do this in your head. Okay, so I've got a little snippet from the book here. It says powers with rational exponents. This is exactly what I was talking about before. Look at this. This is m over n. And look what they did. Exactly what I told you. Because you know that that's the power, that's the root. And sure enough, there's the root, there's the power. Okay? Look again. X to the power of m over n. There's the root, there's the power. Same kind of idea. Okay, so let's do a couple more questions and let's see what we can do. I've got questions here. This is really nice. It says, write the following powers in radical form and then evaluate. In other words, tell me what the number is. Right, so here we go. Let's do this one first. There's the root, there's the power. So this is going to be the square root of 9 to the power of 3. Well, that's easy. The square root of 9 is just 3. So that leaves us 3 to the power of 3, which is 3 times 3 times 3, which is 27. Wow, that was easy. Let's look at this one. Okay, there's the root, there's the power. So this is the cubed root of 27 to the power of 4. And I'll even show you an easier way to do this one right away. The cubed root of 27, of course, is 3 to the power of 4. Watch this. Do this as a factoring tree. Look at this. 3 times 3 times 3 times 3. That is 9. That is 9. 9 times 9, 81. Easy peasy. Okay? Look at this one. There's the power. There's the root. Okay? So it's the 5th root of negative 10 cubed. Now, the only problem with that then is that, how do you evaluate that? What is the 5th root of negative 10? Well, I don't know either. So that's one of the ones that you'll have to bring up your calculator for. Hit clear and go, okay, I want the 5th root. So to do the 5th root, look how awkward this is. You have to go in here and you actually have to use this Dumahajiki right there. Okay? So before we can do that, watch what we have to do. We have to hit second quit. Okay? We have to put in the 5th root, which is 5, then hit math, then hit this guy right down here, mouse down to him, boom, and then put in negative 10, get an answer for that, which is going to give you something ugly, and then raise that whole thing, right, the whole thing, your answer, to the power of 3. Oh my goodness. Okay, giving you negative 3.98. So this is going to, in fact, give you a decimal. Negative 3.98. That's just ugly. Okay, but watch what happens if I use this in exponential form. It's so incredibly easy, and it makes a whole heck of a lot more sense than doing all this mess that you just did. Okay, I want to prove to you that doing it this way will give you the same answer. Watch this. There's negative 10. Let's do it as an exponent. So the exponent of 3 divided by 5. Look how much easier that is. Just knowing to take this and make it into exponent, boom, check it out, same answer. I prefer this over this mess, especially when you're doing it on a calculator. Okay? So you got to be able to flip back and forth. Let's do this one. Exponent, right? There's your power, there's your root. So you want the 8th root of x to the 4 all to the power of 3. Well, how are you going to do that? Well, it's actually a lot easier if you leave it in exponential form. Watch, because exponents tell you when you have an exponent on the outside, what do you do across the bracket? When you go across the bracket, you straight out multiply. So watch this. This is the same as saying 4 times 3 over 8. Well, cancellation law tells us 4 goes into itself once and into 8 2 times. So this is the same as saying x to the 3 over 2, which is, there's the root, square root of x cubed. There you go. So that just makes a whole heck of a lot of sense. Let me write that out a little nicer for you there because you can barely see it. So again, this guy means the square root of x cubed. There, that's nicer. Okay? So either way, you should be flexible in being able to say, okay, I know how to square root, put it in radical form, but I also know how to use the exponents.